Hey, Dinkar.
So Sachin, in last session also, we talked about tech debt and Gen AI and how Gen AI could be a tech debt killer. And
Yeah.
we have talked a bit about this earlier also. So I wanted to do a full session on it because I think it's very interesting a thought, not just from the perspective of it can be done, but it also opens up possibilities and also how to rethink of how software is being done. So before we go in, let's do some basics. So Sachin, what is tech debt?
So, yeah, it's a very good topic and very relevant to today's world. Whenever I have seen people talking about technical debt, they have a set of things in mind. They basically create an umbrella category and anything and everything in their engagement or project, which is they have parked for later refinement. They call that as a technical debt. And the word debt comes from that you need to pay that, so that these are like shortcuts or these are inefficiencies. Some of them get introduced naturally in an organic manner in your code base, and sometimes these are consciously added. Example would be is you are starting brand new on a project and you do not know what the scale would be. Yes, everybody expects we to go and reach million concurrent users on first month of launch, but what if it did not happen? So you don't over-engineer your system. What you do is you create reasonable assumptions about what the scale would be in the first few months, and then design the architecture such that you can serve your immediate customers and don't overcomplicate or over-engineer your solution. And as you start rolling out your product into market and more people start using it, you also understand the pattern. So the idea is sometimes these debts are accrued consciously with purpose, and sometimes these are happening as side effect. Example would be is the biggest technical debt which the whole world paid was log4j upgradation. And it was a 0 day, there was a vulnerability in the code, and people might have had planned to upgrade all their dependencies and libraries, and one day it was a forced hand on them. Everybody needed to modify, update their libraries and everything. So that is what the technical debt is. But let's try to go one level deeper. There are few types of debts which you accrue. These are code debt, design debt. Code debt is typically what everybody talks about. I have written some code and some refactorings are required. Design debt is you created a design in the name of simplification, in name of like lack of understanding.
Sachin, because there's a product manager sitting here and that kind of audience. So design, you mean architectural design?
No, I'm talking about the design, UI, UX design. There is also that architectural design technical debt you accrue. Example, as I mentioned about the scale. Instead of using Kafka, you may go with a simpler queue solution, and later on you will introduce Kafka or some sort of like mechanism. There is a technical environment debt, dependency debt, people process debt. Obviously, that is something which is an evolution. Infrastructure debt, documentation, testing, all like these 9-10 types of debt. I had to read the list. But if you think about all these type of debts which are introduced over a period of time in your code base, when I was actually working with this generative AI and exploration and understanding the impact of all these tools, and the tools which I'm talking about are tools like ChatGPT, tools like Code Assistant.
Sachin, sorry to interrupt. Before we go into the tools, I do want to cover one thing, and I would want you to get started on that first. So debt is something that we have to pay. Sounds fair.
Yeah.
Is it proportional? Like, why should business care about the debt? So in the sense, what I mean by is it proportional is that, oh, I'm behind by, and the typical unit of measure of debt is in time, days, weeks. Well, I was behind, 1 year ago, we took some decisions. 6 months back, we did some analysis. I was 6 weeks behind, let's say. Today, am I still going to be 6 weeks behind? Is it still going to be 6 weeks of additional day? Or does it kind of have an interest? Is it simple interest? Is it compounding interest? So why should business care about tech debt?
Yeah, that's a very good point. Unfortunately, Dinkar, not all debt is measurable. Example would be is if you said the technical debt is measured in days, weeks time, right? That happens when you are doing a static code analysis using SonarQube or some open source tool and library, and it is only measuring the code debt. It is not measuring your dependency debt, or it is not measuring your architectural design. I mean, it does not know by looking at your code how your architecture needs to evolve. Architectural debt would be something is a like holistic view. Okay, what is the scale which we are targeting? What are the non-functional requirements which I need to deal with? What are my business constraints which are coming? Example would be GDPR. One fine day GDPR was introduced and you are launching. And let's not even talk about a historic event like GDPR launch, but your product was launched in only North America. And then now suddenly you are expanding into Europe region and GDPR is applicable to you. Now, when that happens, suddenly you need to be able to ready to deal with those kind of constraints. That's a design. It's not only code debt, but design debt. You need to have infrastructure debt gets introduced. And you can argue with me that, hey, but this is a new feature. But when we were designing the system ground up, certain decisions were made saying, we will not deal with it. So it is not just that you are going to add extension of GDPR compliance, but you are also refactoring some of the earlier design decisions which you took. How you will store data, how will you back it up, how will you implement the delete account functionality or export your data, whatnot, right? So these are various types of dates. You can talk about test. You can't even measure what is your testing fully done or not done. Yes, I can measure test coverage. How much of your code is basically covered using tests. And the way it does is when you run your test suite, it is like looking at how many lines of actual business functionality code it hit during the test execution. So every time a line is called upon, it will say, okay, for line number 233 in file employee.ruby, it was executed. So it is a very rudimentary way of saying, yeah, if the test is actually passing through this code, it might have checked some functionality. But that could also be a dumb way of checking things. So there is no way to know quality of tests. And like quality of test measurement can happen as like escape defects to production and whatnot, but it is very complex matter. And we have seen, right? Technical debt or even overall debt itself is tracked by teams, some in Jira, some in design backlog. Many times the product design teams are different than the engineering teams, and they maintain their own backlog. And when you combine all of that, essentially executives have to think about there is no single view basically which talks about this debt, number one. And number two, even if they consolidate all of it, it is very difficult to quantify. It will be a 2-month or 4-month or 10-month thing. But what actually is deeper question you said, why they should care about it. Maybe quantification is not the goal. What the goal is that what I should do, or what are the markers which I need to think about that my technical debt is going through the roof and I need to address it. Like few markers would be is your customers are actually facing certain errors because of your application is not scaling. Now, that type of thing can be much deeper rather than just like adding 2 servers and one more bigger database into your production systems. It could be also because how you have designed systems or how you are handling customers or how you are serving your assets and whatnot. And these type of all decisions are going to bubble up as symptom into some sort of error. Or in terms of design, any change you are trying to make and like your team is giving you unreasonable, like it mentally feels unreasonable estimate of doing things. You say, hey, I need to actually introduce a new screen in between screen 1 and 2, and they say 3 months. And you talk about why it is 3 months, because I need to rewrite that one whole part of it. Why do you need to rewrite? It's just an intermediate screen. And these conversations are extremely indicative that your team has done something and they need to pay that debt, because either it is not architected well, or either it is not coded well, or you took some assumptions which were not reasonable in real world, all type of things.
And Sachin, you make a very interesting point, and this is again something which a lot of enterprise executives struggle with, right?
Yeah,
They are used to seeing consumer products which evolve very fast, which add features very fast. And then they go back to the team and say, I want this kind of feature. It's just one screen, it's just one button,
exactly.
right? Why does it take so? Why was this startup? What they probably are not aware of. Maybe this is an education for them as executives, and also, for IT teams, that to educate properly is on the concept of tech debt, that at some point over 10, 15 years of managing and building this legacy, there are so many tech debts that nothing is obvious. And, these kind of changes sometimes we have to kind of go back, pay up all the tech debt, and then implement it. And then uh, cost of a program which just wants to add new few screens, suddenly from, hey, maybe it should take a couple of months, it becomes a big transformation program. And that frustrates executives. And I think that is where I think the topic that we wanted to discuss today becomes very relevant. That sometimes what we have noticed is that in legacy, the only way to handle tech debt is to transform, rewrite the whole legacy, re-architect it, use new technologies, relook at all the business rules. It's a whole digital transformation program, right? And then comes along the hypothesis that it's better to just, rather than take legacy and strangulate it and step by step transform it over a period of time, take one MVP, take two MVPs, just bring the whole system down, rewrite the whole system in one go, and voila, right? And that's the hypothesis that not today, but I mean, both of us can see that future coming, where you say to a generative AI that if these are my inputs, these are I give me code that will generate these outputs, and there's so many things that can be done. That probably it's much cheaper to just bring down the whole thing, rewrite the whole thing, and not just do the traditional digital transformation which is happening today. How real is this hypothesis? How close are we, and how would it look like?
We are not there, and I
A
don't see.
lot of digital transformation organization companies, consulting companies are, but it's coming.
Yeah,
We can't say sitting that no one will move my cheese.
see the okay, perfect. So let's talk about that hypothesis and break it down.
Yeah.
I have never seen anybody successfully doing that. Stop everything, rewrite everything, and go live and win completely. It is always open heart surgery in any cases. And the way I see it is possible to attack this problem better with these new tools.
Mhm.
So we may go to that utopian future which you talked about. I don't know that. I do not know a clear path yet. There are multiple steps. So think about today's AI and ChatGPT, right? We are starting to use it from January or December. And then before that, it was all GPT for paper came. Attention is all you need in 2017. But that was not the turning point. This happened after 60 years worth of innovation in artificial intelligence space, like starting from neural networks and everything. So
typical overnight success, which took decades to happen. Yeah.
correct. So today, what we are talking about, like where we are with these tools and their maturity level and our current understanding of our legacy systems, our requirements, between that, there could be these few iterations of technology and tooling may need to evolve to reach to that utopian level where you said, hey, here is my set of requirements, here is my new set of requirements, and I need to reach here. Probably we will not need to transform at all. All you have to do is it will be a very fast iteration to production, essentially. Yeah. So cost of writing software will drop to negligible, and use and throw apps will be very popular. You will write it for Dinker. Like if Dinker has a use case, I will write a simple, just like it is generating a web page today for you, specifically for your query. It will be an application response, something like that. I'm just talking about it, right? But while we are waiting for that to happen, there is a path today. And I think that path is modularity. If you are able to create good enough modular systems, or even, and modularity, I'm not talking about microservices or any specific design pattern. I'm talking about even in a classical monolith application, you can create very modular systems as components, as libraries. And these are going to be extremely important. So if you do that, essentially the whole, that particular part of your application can be potentially replaced. And to do that, you will be able to take help of all these tools to explain the existing code. That is a bigger challenge. Many companies do not undertake the risk of strangulation or removing legacy because, they never understand fully what was written earlier. And I have seen it myself. A code which I have written 5 years ago, I don't understand why I wrote it that way. And it is a mental chore. You have to stress your brain a lot to understand how it was written. And if these tools are smart enough to assist you, and they will just get better, is what my understanding is, you will be able to understand it. And that will remove a major mental barrier of, hey, I don't understand this, so I don't want to delete this. I don't want to change this. That will go away. Second is, if you have these modular systems and you have ability to understand this code, before even you can start strangulation, you can write test cases. The cost of test case writing is very low now. So one of the biggest challenge of legacy modernization is that not able to validate whether the new code is mimicking existing code. So you said, right, hey, here is a set of inputs and here are the set of outputs. Now that is what generative AI can do really well. If you are able to show code, you are able to show some methods, and you say, hey, I want to write some test cases, but like explain me code. It may be time consuming. It is not going to be automated, like click, click, click. It may be, but it will take a week of time for, let's say, 2 modules, and you will be able to do far superior job than not having anything at all, and not able to do it in a month's time. My feeling is that it will provide us that confidence that I can actually change this thing now. And then once you start creating this modular approach, best part would be is you will be able to automatically generate documentation. One of the biggest problem of software industry is that developers are not good at writing documentations. Now, some people might get mad at me for saying this, but I have never seen majority of developers not writing good documentation. In fact, I have many times got frustrated. Like there was a method about apply settings. And so it is like the method is like in a setting class, there is an apply method, and it will take set of like parameters. And it says, this method applies settings. Yes, I understand. This is a setting class, and this is the apply, and it takes a dictionary. What are the side effects of this? If it applies setting and it fails, what does it do? Nobody writes this type of things. And these are the problems which needs to be addressed. How these type of things happen. You will be able to do this so that next time you come and revisit this code, it will be far easier for you to handle. I have seen writing test cases, writing documentation, explaining your existing code, also helping you to debug existing code if there is a bug. It is really good at. And these were the dirty activities which required a lot of intricate knowledge, experience, and that's why people would not be able to get fired, to be very honest. In many cases, I have seen that people capture a corner of application which they only know about it, and companies are afraid of these people leaving, and it's a big challenge. I mean, I have no intention that okay, this should be making people disposable, but my point is that everybody
their value should not be guarding knowledge,
correct.
but their value should be continuously improving it. I mean, go back to the basics of creating rather than maintaining.
Very well said. Exactly. It should not, we should not keep the knowledge hostage with you
Hmm.
in any part of the company. And if you think about what examples I took, right, you can address test related debt, you can address documentation related debt, you can address the debt of code, you can, to a some extent, you can also address the architectural debt in a way. So this is, I'm talking about only your editor and pair, like GitHub Copilot or Codium, or there are like Code9 and 5 other tools. But if you combine chat with this, and nowadays those are also available in Codium, in GitHub Copilot chat, and there are more tools which are coming in. It's a deadly combination. Right in the editor, you are able to ask questions about your own code, get answers. You are able to ask questions related to, hey, I have these two pieces, and I need to actually send this over the wire. What are my options of encryption of this data?
Yeah.
Now, these type of brainstorming activity used to take so long. Now it can be done easily. And
Or
these,
something like summarize my code and then quickly read through it and use it as a comment
yes,
to
yes, and
explain the purpose of the code. Yeah.
yes, and this and all of the above. So the only places where I see that more human intervention will be required will be design debt, where you need to design, like understand what user experience is there, what are the drawbacks, and what you need to do. You will need to focus more on architectural debt. You need to understand what are the non-functional requirements, because today, at least today, these tools don't have a holistic system view. So you need to think about that. In terms of
Sorry to interrupt there, Sachin. On this, I think there is a possibility of a new tool. Maybe someone can build it, or we may end up thinking about it as, in evolutionary architecture, ThoughtWorks has a position of fitness functions, right? You write fitness functions against an algorithm or an architecture, and over a period of time, it keeps on ensuring that the purpose is being met, cross-functional requirements, business outcomes, whatever, right? It's almost like there is going to be a tool to which kind of goes through the fitness functions. And as you said, right, as fitness functions evolve, or it kind of goes and analyzes, and maybe that's the tool which can take care of architectural tech debt.
It may very well. I mean, again, to me, there are few pieces which needs to be in place before that type of thinking can happen.
Yeah.
But it is not far from grasp. There is a path to that. The way you explain, add 2 more steps or remove 2 more steps, like alter a few steps. There is a path to it. You can logically think about it. And when you can logically break down a problem into smaller components, there is a high potential that somebody will code for. So yes, it is possible. So I'm excited that with these tools, now I can go and start like modifying, experimenting with parts of code which were literally, these were the neighborhoods of my code bases which I was very afraid to walk into. Like after dark, don't go into these neighborhoods, right?
Yeah.
So
otherwise debt collectors will show up and say, Sachin, pay up your debt.
Exactly. But
those
will actually go away. And if you create modular like systems itself, my feeling is that, Dinkar, you don't need to create very sophisticated tools to do what you just earlier at the beginning said, is delete this. Hey, here is the few things. I want to rewrite this.
Yeah.
With these new 2 features. And I'm hopeful that at least today, it's a sliding scale. So earlier we had 0 augmentation. And let's say this is that utopian picture on the right-hand side. There is now a sliding scale. Somewhere in between here we are there, like 30–40%. So the augmentation is very powerful today, which did not allow me to do what I can do today. But this is going to get better. And eventually, I don't know whether it in 6 months or 12 months or 5 years, we will reach to a place where technical debt wouldn't be scary at all. Our tool sets will be so rich and so powerful that we will be able to deal with this technical debt in a far superior fashion. Today, what we have access to, if we just forget about all the like the ethical and legal barriers of entry for these tools into your code base and enterprise, if you forget about them for now, for a moment, the tool set, what I have seen, is powerful enough that you can do far more, which you could not do in months. Now you can do in days.
Yeah. So as a summary, Sachin, that uh, tech debt is very important,
Yes.
especially in enterprises, especially when you're looking at legacy. And execs need to understand this concept so they can understand why certain things are so hard to do. And there is a new set of tools, new ways of working which are emerging that can help you pay these debts much faster with at much less cost. And teams are exploring it. A lot of organizations are looking at how to get it in, and the executives should also encourage or make it possible for their IT teams to explore these teams by giving them all the related business and legal and all those kind of covers. And the original principles still stand of transformation. It's just that with these new tools, those chores, very heavy activities, sometimes very boring activities, now can be automated much faster. And people are focusing more on validation and ensuring things are correct. And handling tech debt is becoming a much easier value proposition than before.
Yeah, definitely. It scares me a lot less. And to just what you in during your summary said, I do believe there is an increased awareness of technical debt in executives. I am very happy about it. And they are also aware of the side effects of it. So it is easier today to negotiate and allocate a budget. The only problem is that many times these debts are not supposed to exist, and those are accrued by the teams. But I'm hoping that
That's also part of learning that these kind of things happen. And I think sometimes in future we should spend time on. We have talked about ebometrics, but I think we have never talked about the tool that you and I built. And there's an awesome
yeah,
set of product managers and developers in ThoughtWorks who and some partners who made it happen, called ThoughtWorks Polaris. Maybe we should talk about the reason while it is a shameless plugin for ThoughtWorks Polaris, but the reason I brought it up is whenever we have talked about ebometrics and we have demoed ThoughtWorks Polaris to executives, the questions around tech debt and their awareness is something that you alluded to, that there's much more awareness of these certain technical metrics among business executives, which is a very good sign.
right. Absolutely.
Cool. And this was very useful, Sachin. Thanks a lot. I know you're on your vacation time. Thanks for stepping aside from your fun and frolic to talk about this fun topic.
This is fun.
Okay.
Thank you so much.
Yeah. Take care. Bye-bye.
Bye.